Welcome guys, this is question 5.38 and the statement it has is among 150 IRS employees in a large city, only 30 are women. Okay, 150 are the total employees and 30 of them are women. If 10 of the employees are chosen at random to provide free tax assistance for the residents of the city, use the binomial approximation. Okay, we have to keep it in our mind to the hypergeometric distribution to find the probability that at least 3 women are selected. Okay, so let me first write the given data. Okay, in a city we have a total employees 150, out of them 30 are women. Okay, and now out of these 150, 10 are randomly selected. Okay, so this is clearly the case of the hypergeometric distribution where 3 women has to be selected. So now in order to find out here the probability that x is greater or equal to 3, if x is a random variable which is basically the number of women out of these 10, it can also be written as 1 minus the probability that x is less than 3. Okay, then in order to find out this probability, what we can do, we can write here x is less than 3. For it, all the less than 3 values would be the probability that x is equal to 0 plus the probability that x is equal to 1 plus probability that x is equal to 2. Okay, these are all the values. Then it can be written as, if I write this as x equal to 0 up to 2, okay, this is the small x, it can be written as probability that x is equal to small x. Okay, this is what we have. Now let me proceed it by going somehow downwards. Okay, so it is what I can very easily write here, the hypergeometric probability distribution. From it, the total number of items are 150, out of them 10 are selected. Okay, then if I want to find out the number of women out of these 10, the number of women from in the total number of items are 30. From it, if I have to select the items which are x, it would be here. Add the remaining items which are the men are 120, and the remaining item would here become 10, which are the total number of selected item minus the number of women which are selected, and it would be for what? It would be for all the values from 0 to 2, and this is what? This would be the probability that x is less than 3. Then taking this value, putting it here, we can find our solution. Okay, this is by using the hypergeometric probability distribution, but the question and the scenario here is that this would be a very huge number, because here you can see that this is a number very huge, this one will be very huge, this one also be very huge, so it wouldn't be computationally very feasible to find it out. So despite it, what we can do here is that, as given in this question, we can use binomial distribution approximation. Okay, so in order to do the binomial distribution approximation, what we have to do, out of this we have to find the probability of x, which is the p, the probability of women in the number of employees. So it would be 30 divided by 150, so it would be 0.2. Now this is the probability of the women out of this 150, which is the population size. Now out of this population, we have selected this sample, and out of these samples I have to find out the probability that women selected are at least 3. So again here we have, this is the probability which is given, the number of items here now we have 10, while the values of k would be 0, 1 and 2. Okay, we have to find them out and then subtract them from 1. So it would be the probability that x is greater or equal to 3. It would be 1 minus the probability that x is greater than 2. Using the binomial probability, what we can write here, it would be the binomial, okay, where the values of k will be here, and also the number of samples are 10 and the probability is 0.2. Okay, so let me solve it for this case, and it is probability that x is greater or equal to 3. So let me solve it by going downwards. Okay, so here we have, so this is what, this is the probability that x is greater or equal to 3. So it would be 1 minus this binomial. So writing it here, it would be for x is equal to 0 up to 2, and it is what, it is 10, choose x. Okay, and then the probability, which is 0.2, taking it, writing here x, and 1 minus 0.2, 10 minus x. Okay, so let me write these values. It would be for all the values of x, it would be 10, choose 0. For the first one here, it would be 0.2, 0, and 0.8, 10. Okay, plus, let me use it like this. Similarly, 10, choose 1, 0.2, 1, and 0.8, 9, because this is 10 minus 1 is 9. Okay, similarly, the last one, 10, choose 2, 0.2 raised to power 2, and 0.8, 10 minus 2 is 8. So this is what we will find. So after finding it out, subtracting it from 8, what we will get, it would be 0.323. Okay, so that is what, that is basically the solution of our question. From this question and from this, you can also find out the similar solution, but it wouldn't be that much computationally easier as we have done it here. Okay, so that's it for today, in which we have seen the binomial approximation for the hypergeometric probability problem. So if you have any question, you can ask me in the comment box. See you soon.